I'm tackling a problem where I'm using scikit-learn's gaussianprocessor to model some data. I suspect there's a constant offset in the underlying function, and I'm going to use the ConstantKernel to handle this. This question asks which statements about the kernel are true. This is a multiple-choice question testing your understanding of the ConstantKernel in Gaussian process regression, GPR, using scikit-learn. I'm using gaussianprocessor, a function in the scikit-learn library, to build a model. It uses Gaussian processes which are non-parametric Bayesian methods. This question is of multiple choice type where you need to select all true statements. Statement A says the ConstantKernel adds a constant value to the prediction, regardless of the input. I'm checking if that's accurate. Think of it like adding a fixed baseline to your predictions. Statement B claims that the constant underscore value of the ConstantKernel is automatically learned during the model training by MLE, maximum likelihood estimation. I need to verify whether this is true. MLE is an optimization technique. Statement C suggests that using the ConstantKernel always improves the results. I'm checking if this is always true or only sometimes. It's crucial to remember that adding a ConstantKernel isn't a magic bullet. Statement D proposes that the ConstantKernel is the same as adding a bias term to linear regression. I need to check if this analogy holds true. Let's find out if there is similarity or if they differ. This question tests your knowledge of the constant kernel in scikit-learn's Gaussian process framework. I'll guide you through analyzing each statement to determine its truthfulness. We'll explore how the constant kernel functions and interacts with the Gaussian process regression model. Let's get started. This statement is absolutely correct. The constant kernel directly shifts the prediction up or down by a fixed amount. Think of it like adding a constant bias to your predictions. It doesn't matter what the input is. The offset remains the same. This is also true. The constant kernel has a hyperparameter, _constant_value, representing the constant offset magnitude. During model fitting, scikit-learn uses an optimization technique, often maximum likelihood estimation, MLE, to find the best _constant_value that maximizes the likelihood of observing the data. In simpler terms, it finds the best constant offset for the data. I'm afraid that's incorrect. While it can improve the model if there's a true constant offset in the data, adding it unnecessarily might worsen performance. Sometimes, adding extra complexity without a genuine need will not be beneficial. It's crucial to consider whether your data actually has such an offset. That's not quite right. Although both introduce a constant offset, they work differently. A linear regression bias term is added directly to the linear equation, impacting the prediction in a straightforward way. In contrast, the constant kernel modifies the covariance structure within the Gaussian process, influencing predictions indirectly through its effect on the covariance. This refers to using the Gaussian process regression, GPR, method with the constant kernel. GPR is a powerful Bayesian method for regression, and the constant kernel is a specific kernel that lets you model constant offsets within the data. This combination is used for modeling datasets where a constant shift or bias might be present. This is the process of using the training data to find the optimal parameters for the model. In the context of Gaussian process regression with the constant kernel, this involves finding the optimal _constant_value as discussed above. I'm asking you to understand how scikit-learn's gaussianprocessor uses the ConstantKernel. We're using it to model data where I suspect a constant value is added to the output, regardless of input features. Let's see if you can figure out what's going on. This statement is correct. The ConstantKernel literally adds a constant number to every prediction, ignoring the input features. Think of it like adding a fixed bias to your prediction. Correct again. The ConstantKernel has a parameter called ConstantValue. During model training, the algorithm uses maximum likelihood estimation, MLE, to find the best value for this parameter that fits the data. MLE essentially finds the parameter values that make the observed data most likely. This is incorrect. Using a ConstantKernel only helps if there's an actual constant offset in the data. If there is not, it could reduce the performance. Nope. While both introduce a constant value, they do it in totally different ways. A bias term in linear regression adds a constant directly to the linear equation. However, the ConstantKernel modifies the covariance in Gaussian process regression. They're not interchangeable. This reinforces statement A. I'm reiterating that the ConstantKernel just adds a fixed number to each prediction. It's a simple yet effective way to model constant offsets in the data. This summarizes statement B. I'm highlighting that the ConstantValue isn't something you manually set. The algorithm learns it from your data using the MLE method. This is the core question of the quiz. I'm testing your understanding of the ConstantKernel's role in Gaussian process regression, GPR, within the scikit-learn library. I'm asking whether you know how the ConstantKernel's key parameter, constant_value, is determined. It's crucial to know that GPR models often use maximum likelihood estimation, or MLE, to find the optimal values for their hyperparameters, including the constant_value for the ConstantKernel. Think of MLE as a process to find the parameter values that make the model most likely given the data. Here, I test whether you understand that simply adding the ConstantKernel doesn't guarantee improvement. Sometimes, adding a constant offset when it's not needed can harm the model's accuracy. It's essential to only include it if there's reason to believe the underlying data has a constant offset. I'm checking if you understand the basic function of the ConstantKernel. It directly adds a fixed value to the prediction made by the model, regardless of the input features. This is its primary purpose, to account for a constant bias in the data. This sets the stage. I'm focusing on a common problem in modeling, dealing with constant offsets, or biases, in datasets. I want to see how you'd solve it using scikit-learn's Gaussian process regressor and the ConstantKernel. This introduces the core technique, GPR, with the specific use of the ConstantKernel. I will assess your knowledge of this specific combination within the context of scikit-learn. I want to test your understanding of how the ConstantKernel modifies the core GPR behavior. This elaborates on the method used to determine the best value for the ConstantKernel's hyperparameter. MLE helps the model learn the value for the constant added to the prediction by the ConstantKernel. This highlights the broader context of where these hyperparameter optimization techniques occur. Model fitting. The process of finding the optimal constant_value happens when the GPR model is fitted to the data. I'm using Gaussian process regression, a fancy way to predict values, and I'm adding a special ingredient called a ConstantKernel. This kernel helps me account for a possible constant shift in my data. GPR is a non-parametric Bayesian method, meaning it doesn't assume a specific form for the function it's modeling and uses Bayesian statistics to do so. It uses kernels, functions that define the relationship between data points, to make predictions. The ConstantKernel is one such kernel. I have some data, and I suspect it has a consistent shift or bias. Think of it like consistently weighing items on a scale that's slightly off. All weights are off by the same amount. To deal with this, I want to use the ConstantKernel in my Gaussian process regression model. My solution is straightforward. I'll add the ConstantKernel to my GPR model. The ConstantKernel's job is to account for that constant offset in my data. This will help me get a better fit to my data if indeed that constant offset is there. This statement is absolutely correct. The ConstantKernel adds a fixed value to each prediction. It's like adding a constant to the result of my calculation, no matter what the input is. This one is also true. The ConstantKernel has a parameter that represents the size of the constant offset. My model will automatically figure out the best value for this parameter using maximum likelihood estimation. MLE is a statistical technique to find the most likely value of a parameter based on the observed data. This statement is false. Adding a constant kernel will only improve things if a real constant offset exists. If the offset is negligible or non-existent, adding this kernel will only complicate the model and potentially hurt performance. This is incorrect. While both achieve a constant shift, they do it in very different ways. A bias term in linear regression is a direct additive term, while the constant kernel modifies the covariance function in the GPR model. They're conceptually similar, but their implementation differs greatly. I'm asking you to determine which statements correctly describe how the constant kernel functions within scikit-learn's Gaussian process regressor. We'll analyze each statement to see if it aligns with the kernel's behavior. Let's dive in. This statement is correct. The constant kernel, as its name suggests, adds a fixed value to every prediction. Think of it as a constant vertical shift to your prediction curve. It doesn't depend on the input data. It's simply a constant addition to the model's output. This is also correct. The constant value isn't something you manually set. The model learns the optimal value for it during training. Maximum likelihood estimation, MLE, is a common method used to find the best fitting constant value maximizing the likelihood of the observed data given the model. Pretty neat, huh? This statement is incorrect. While a constant kernel can improve performance if a constant offset is present in the data, it's not a guaranteed performance boost. In fact, adding it when unnecessary could decrease your model's accuracy. Think of it like adding extra ingredients to a recipe. Sometimes it helps, but other times it messes up the flavor. This is incorrect. While both add a constant, they operate differently. A bias term in linear regression directly shifts the regression line, whereas the constant kernel adjusts the covariance structure in the Gaussian process. They achieve a similar outcome, a constant offset, but the underlying mechanism is different. It's important to understand the nuanced difference. I'm using Gaussian process regression, GPR, a non-parametric Bayesian approach, with a constant kernel to model my data. GPR models the relationships between data points by considering them as a sample from a Gaussian process, while the constant kernel adds a constant offset in the prediction. This makes the model more robust to situations where there is constant bias in the dataset. Let me know if you need any clarification on this. This instruction tells us that more than one answer might be correct, so we'll need to carefully consider each statement. This is a multiple selection question, meaning you are to select all options that are correct, not just the most correct one. I see you're using Gaussian process regression, a powerful tool for prediction. It's a Bayesian method, meaning it uses probability to estimate the function that best fits your data. The constant kernel is a special component that adds a constant value to the model, accounting for any baseline offset in the data. Okay, let's dive into this multiple choice question. We're checking our understanding of how the constant kernel works in scikit-learn's Gaussian process regressor. This statement is true. The constant kernel's core job is to add a fixed number to every prediction, no matter what your input data looks like. Think of it like adding a baseline shift to your predictions. Absolutely true. The model doesn't just use a random constant. It cleverly figures out the best constant value to use during the training phase. MLE is a common technique for optimizing hyperparameters in machine learning. It finds the parameter values that best explain the observed data. This one is FALSE. Adding a constant kernel only helps if your data actually has a consistent offset. Otherwise, it might add extra complexity without any benefit, even potentially harming the model's accuracy. This is FALSE. Although both introduce a constant shift, they do so in very different ways, affecting separate parts of their respective models. The bias term in linear regression is directly added to the linear combination of features, while the constant kernel influences the underlying covariance structure of the Gaussian process model. They aren't interchangeable. Here are the choices. Let's evaluate each one carefully to ensure we choose the right answer.